Light is all around us, and it's one of the most fundamental aspects of our universe. But how much do we really understand about light? In this video, we'll explore the science of light, what it is, how it behaves, and the incredible impact it has on life here on Earth. At the most basic level, light is a form of electromagnetic radiation. This means that light is made up of waves of electric and magnetic fields oscillating at different frequencies. These waves travel through space at the speed of light, about 300,000 kilometers per second, or roughly 186,000 miles per second. This speed is so fast that light can travel around the Earth almost 7.5 times in a single second. But despite its incredible speed, light behaves in mysterious and fascinating ways that scientists continue to study. One of the most important characteristics of light is its wavelength. Light comes in many different wavelengths, and each wavelength corresponds to a different color. The visible light spectrum, the range of light that human eyes can see, is made up of wavelengths that range from around 400 nanometers, violet, to about 700 nanometers, red. This range includes all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. The colors we see are a result of light being absorbed, reflected, or transmitted by objects in our environment. When light hits an object, certain wavelengths are absorbed, and others are reflected. The wavelengths that are reflected back into our eyes are what give us the colors we perceive. For instance, a red apple appears red because it reflects light in the red part of the spectrum and absorbs the rest of the colors. But visible light is just a tiny part of the electromagnetic spectrum. In fact, most of the electromagnetic spectrum consists of light that we can't see, such as radio waves, microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. Each of these forms of radiation has a different wavelength and energy level, and they all behave differently when they interact with matter. For example, infrared light has longer wavelengths than visible light, and it's often associated with heat. This is why we feel warmth when standing in sunlight, as infrared radiation carries energy that is absorbed by our skin. On the other hand, ultraviolet light has shorter wavelengths and higher energy, which is why it can damage our skin, causing sunburns. X-rays and gamma rays have even shorter wavelengths and higher energy. These types of light can penetrate through materials and are used in medical imaging and cancer treatments. The ability of X-rays to pass through the body and create images of our bones is thanks to their high energy and short wavelength. However, the same properties make X-rays dangerous in large doses, which is why their use is carefully controlled. When light interacts with objects, it can be reflected, refracted, or absorbed. Reflection occurs when light bounces off a surface, such as when you see your reflection in a mirror. Refraction happens when light passes through a substance, like water or glass, and bends. This is why a straw looks bent when it's in a glass of water. Absorption occurs when light is taken in by an object, such as when a black surface absorbs more light and becomes hotter than a white surface, which reflects most of the light it receives. Refraction and reflection are key principles in optics, the branch of science that deals with the behavior of light, and they play an essential role in technologies like eyeglasses, microscopes, and telescopes. One of the most fascinating properties of light is that it can behave both as a wave and as a particle. This duality is one of the cornerstones of quantum mechanics. In some situations, light acts like a wave, traveling in undulating patterns and carrying energy through space. In other situations, light behaves like a particle, called a photon, with energy that is concentrated in tiny packets. This duality was famously demonstrated in the double-slit experiment, where light passing through two slits creates an interference pattern on a screen, showing its wave-like nature. Yet, when light is observed closely, it behaves like discrete particles, or photons. The way light travels through space is also a critical aspect of our understanding of the universe. Light from distant stars and galaxies takes years, centuries, and even millions of years to reach us. The farther a star is from Earth, the longer it takes for its light to travel across space. This means that when we look up at the night sky, we're actually seeing stars as they were in the past, not as they are right now. The farther away a star is, the older the light we see. This concept also allows scientists to study the past of the universe. For example, by looking at the light from distant galaxies, astronomers can study the conditions of the universe shortly after the Big Bang. The study of this ancient light, known as cosmic microwave background radiation, has provided valuable insight into the origins and evolution of the universe. The light we see from stars and galaxies gives us clues about the age, composition, and even the fate of the universe. Light is also essential to life on Earth. Plants rely on sunlight for photosynthesis, the process by which they convert light energy into chemical energy to fuel their growth. Without light, plants would not be able to produce the oxygen that we breathe, and life on Earth would not exist as we know it. Sunlight also plays a crucial role in regulating our daily biological rhythms, known as circadian rhythms. Our bodies rely on the natural cycle of day and night, which is influenced by the light from the sun, to regulate sleep patterns, hormone production, and metabolism. This is why exposure to natural light during the day is important for maintaining good health. The invention of artificial light revolutionized human society. Before the discovery of electricity, people were dependent on fire for light, which was limited and dangerous. The development of light bulbs in the late 19th century, followed by more advanced lighting technologies, allowed people to work, socialize, and engage in activities after the sun had set. This has had a profound impact on our culture and lifestyle, extending the day, changing our work habits, and creating new opportunities for innovation and creativity. In modern times, light is used in countless technologies, from fiber optic communication, which uses light to transmit data at incredible speeds, to lasers, which are used in medicine, manufacturing, and entertainment. Lasers concentrate light into a single, coherent beam that can be used for everything from cutting and welding materials to scanning barcodes and performing delicate eye surgeries. The power and precision of lasers have led to innovations across various fields, including scientific research, art, and technology. Light is also essential in the field of photography and optics. Cameras rely on light to capture images, and lenses are used to focus light onto film or digital sensors. The study of optics, or the behavior of light, has led to incredible advancements in telescopes, microscopes, and other instruments that allow us to observe the universe on both large and small scales. These advances have allowed us to peer deep into space and uncover the mysteries of the cosmos, as well as study the microscopic world in unprecedented detail. In the field of physics, light continues to be a topic of great interest. The study of light has led to groundbreaking discoveries in quantum mechanics, general relativity, and even the understanding of the nature of time and space. The speed of light is a fundamental constant in Einstein's theory of relativity, which revolutionized our understanding of how space and time are interconnected. This theory has had profound implications for the way we view the universe, space travel, and even black holes. As we continue to explore the properties and uses of light, we uncover more and more about the universe and our place within it. Whether it's through the study of distant galaxies, the development of new technologies, or the ways in which light influences our daily lives, light remains one of the most powerful forces in both science and society.